Hello and welcome back to another video. In this problem, we're asked to explain why the function is discontinuous if the given number a and to sketch a graph of the function. So we have f of x is equal to x squared minus x over x squared minus 1 if x is not equal to 1, and 1 if x is equal to 1. So a function is continuous if the limit as x approaches a of f of x is equal to f of a. So let's find the limit, because we know that for a equals 1, f of 1, we know is 1 just because if x equals 1, the function equals 1. So we have to find the limit and show that it is not equal to 1 for it to be discontinuous. So if the function is not equal, if x is not equal to 1, the function is equal to this. So the behavior of the function as x approaches 1 is going to be of this function, x squared minus x over x minus 1. So we have the limit as x approaches 1 of x squared minus x over x squared minus 1. We want to simplify this. This is x times x minus 1 over x plus 1 times x minus 1. So we can cancel this. We do lose the domain restriction where x minus 1 cannot be equal to 0. Therefore, x cannot be equal to 1. But since we're looking at the limit as x approaches no 1, not what's happening at 1, we're just looking at the limit for now. We can say that this is equal to the limit as x approaches 1 of x over x plus 1. Now we don't have a domain restriction, right? Before, the reason we're doing this whole simplification is because if we just plugged in 1 directly, we'd be dividing by 0. And you can't do that. But now we can plug in 1 directly to get 1 over 1 plus 1, which is 1 over 2, which is 1/2. Therefore, the limit as x approaches 1 of f of x is equal to 1/2. And this is not equal to f of 1, therefore the function is discontinuous. So we're also asked to sketch the graph of this function. This is not a graph which we are familiar with or can easily find through transformations. So I think the easiest way to demonstrate how to find this is just to plot some points. So we know that at x equals 1, we're not going to have any, at x equals 1, we're not going to be using this, right? If x equals 1, f of x equals 1. We also have to pick some points near 1. So we can try 0.5, 1.5, 0, and 2. And we simply have to plug in, let's say 0.5 squared minus 0.5 over 0.5 squared minus 1. And if I just plug that into a calculator, we get that this is equal to 0.3 repeating. 1.5 we get that this is equal 1.5 squared minus 1.5 over 1.5 squared minus 1. This is equal to 0.6, not repeating, just 0.6. 0 is going to be 0 squared minus 0 over 0 squared minus 1. This is just equal to 0. And finally, 2 is going to be 2 squared minus 2 over 2 squared minus 1, and this is 0.6 repeating. So with just a couple points, we can now graph the function, and it's not going to be perfect, but it'll be close enough. We have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. I'll actually add 4 and say that we have 1, 1, negative 1, negative 1, so each tick is 0.5. So we have the function at 1, 1, at 0.5, 0.3, 1.5, 0.6, 0, 0, and 2, 0.6. So we can see that we have this point here, and then remember that the rest of this is a continuous function, right? Except for that one discontinuity. So you have sort of a circle here to denote that the function is not equal to it at that point, but at all other points, we are equal to this function. So this is a rough graph of the function, which also shows that at x equals 1, the function is discontinuous.